Good morning, everyone. This is Aswin from BreviTV, and here I am to explain you the tree data structure and its traversals too. So, without wasting any further delay, let's directly jump onto the topic. So here I'll be telling you about what are we gonna cover in this video. So we are basically going to let's say I'm thinking, okay, so we are basically going to cover some little bit of introduction and what are the types of trees we are gonna see, and also a little bit of tree traversals. There are basic traversals in tree which we will be covering and we'll be coding as well. Okay, so the first question is, how does a tree data structure look? And here you go. This is how it looks. So we have few circles here, and these are basically called nodes. And if you can recollect, tree data structure is actually similar to one dot of a linked list. We have a linked list node here. We have a linked list node here as well. We had a linked list node here as well. It's connected with some pointer. This is connected with another pointer. And there are three other pointers for which these three nodes are connected. So this is how this basically works. We are actually extending a linked list into a particular data structure. So now let's look upon few other terminologies what we are going to have. Okay, so as I've already told you, the red end circles are actually called nodes, and then the topmost node in a tree is called a root. Root occurs in a tree, it's topmost, rather generally it's bottom, but here it is top, so please don't get confused. Root is at the top of the tree, and then here we have parent nodes. This is a parent node, this is a parent node, and this is also a parent node, because it has further children. Root is also a parent node if it has children. 10 and 10, 12 and 15 are root's children, and we have 20, 40 and 50 as 10's children. So 10 is a parent, and all these nodes which are underlying beneath are leaves nodes or child nodes. So these are the basic terminologies. These are pointers. We have left pointer and right pointer, but we may have more than one pointers as well. Let's further see what we can learn from trees. Let's explore further. So let's see the types of trees which we are going to have. And we basically have a lot of trees here. The main concept in this video which I'm going to give is on binary trees. And there are a lot of binary tree subdivisions as well. There's search tree, there's AVL tree, and there's lead black trees. And there are other trees based on key value. This is basically for your searching optimization. So the time complexity decreases. Here we have B trees, suffix trees, and radix trees for that. And this is on space partition. So in order to increase the space complexity, we have segment tree and as well as range tree. But in this particular video, we'll be looking on binary trees and only binary trees, not even the search tree, AVL tree, and red black. That we will be posting out soon. Okay, so let's go into it. So here we have a binary tree here. I'll give you a small introduction on a binary tree. So in a binary tree, you actually have a root and a few other nodes as well. And it has left pointer and right pointer, and it will be connected to two other nodes. Okay. So, and it will be having two pointers. One is the left pointer and one is the right pointer. That's all we need to know about a binary tree. It has it doesn't have more than two children. Maximum it has two children, that's pretty much it. Let's just explore a little bit more in the binary tree in the coming videos. In the coming time you can understand it. Let's go. Okay, so before we begin into a binary tree, let's see what our Talivar says.
Hey, what?
He actually says this means nothing, the word lies in 8. Okay, I'm saying this because even the tree example which we are going to take has 8 nodes. We have one as the root node. As you can already see, it's separated by the blue color markings which we are given, and these are the parent nodes. So parent nodes are like this, and these are the leaves nodes. So we have a leaf shape structure here, and here is what the example is be giving. Here is our world. So 1, 2, 3, 4, 5, 6, 7 and 8 is pretty much our tree. So we are going to work with this particular example for us. So before going into tree traversals, I'll actually okay, so this is our world. I did that post. So this is our world, and first we'll try to make this tree. Okay, so we're gonna go into Visual Studio Code and we're gonna code that tree. So as you have already seen, we have a node structure here. So we'll be having a node, and we'll be having a data which is the whole nodes, and then node will be having a left pointer as well as a right pointer. And in order to create a node, we use a constructor, And in case if we call an empty constructor, let's say the data is 0 and the left pointer and the right pointer is nothing much, none. Okay, in case we call a value to the node, let's say we are calling a value and creating a node, and that time the data becomes D, and then the left and the right is pretty much null again. So this is how we are going to create the tree. This is pretty much the structure which we have. Let's end it with a semicolon. So we're going to create this tree, right? So one is our root. So let's go and create our root. So we have root is new node 1. Okay, this is our pretty much root, and we can see 1 is connected to 2 and 3, 2 is connected to 4 and 5, 3 is connected to 6 and 7, and 4 is connected to 8 as well. So let's go and make this structure. So we're gonna have roots left is new node 2, and roots right is new node 3, roots left is new node 4, and roots right is new node 5, roots left is new node 6, roots right is new node 7, and whatever we have created the 4, we have roots left right is new node 8. So here we have created the tree, and we have to check whether we have created the tree correctly. So here we'll be going to see some amount of binary tree traversals. Okay, so before we go into binary tree traversals, let's just take a little bit of break. So here you go, let's begin with the tree traversals here. So there are 4 types of traversals. One is pre-order traversal, in order, post order, and level order. We'll be looking at them individually. So let's start with pre-order. Okay, so this is pretty much easy. So the algorithm for pre-order is, you can see here, it's node left and right. Okay, so I'll be explaining you this, and I'll be explaining other traversals as well, but you can pause the video and you can get it on your own. I'll just be coding for that particular path. Okay, so let's I'll just explain this to you. So we have a node here, okay, and once we see the node, we're gonna print it. Okay, so we're gonna print 1, and then we're gonna go left. We're gonna go left, and we're gonna follow the same thing. We're gonna follow node left and right. We're gonna see a node, we're gonna print it. Okay, so now we have 1 and 2. Now again we go left. So we have 4, and again we follow node left and right. So we have 4 here, and we print 4. Okay, so we have 4. Now after printing 4, do we have anything on left? No, we don't. But do we have anything on right? Yes, 8. For 8 again we follow node left and right. So we print 8 here, and then it's pretty much done. We have no left, we have no right, so we return. 4's left is done, right is done, we return. 2's left is done, so we go 2's right. So we can see 5 here. So for 5, we're gonna pretty much follow node left and right, so we print 5 here. Okay, so we're gonna print 5 here. I'm sorry for that. We're gonna print 5 here. 2's left is done, 2's right is done, we're gonna return. So 1 is done, 1's left is done, we're gonna go 1's right. So here we go 3, and for 3 we follow node left and right again. So here we print 3. Okay, then after 3 we're gonna 3's go left. After 3 is left, we go to 6. 6 again we're gonna print 6. And then there's no left, there's no right, so that's done. 3's left is done, we go 3's right. There's 7, there's nothing on 7's left, 7's right, so this pretty much is going to be printed. Okay, so this is how it's going to work. We have node, and then we have left, we have right. Okay, so basic algorithm is, if you see a node, you print it, and then you go to its left, and then you go to its right. Okay, this is pretty much the output. We're gonna code it in a very simple way. Okay, here you go. So what I'm going to do is I'm going to print the pre-ordered traversal of the tree, and let's make a function of pre-order and root. Okay, so before that we'll put a slash in as well. Okay, so here we have pre-order, and then we're gonna have a root here. So what did I say? If the root exists, if there is a root, then we just print root's data. Okay, if root exists, we just print root data. And then if root's left exists, then nothing, we just pass the same tree into the function. So we're gonna pass root's left here, and if root's right exists, we're gonna do the same thing, we pass root's right here. So let's just test this function. And here you go. So we have G++, we have main.cpp. Okay, that's taking a little bit of time. Okay, hurry up. Here you go. So we have pre-order traversal. We have 1, 2, 4, 8, 5, 3, 6, 7, and that is pretty much it. So this is pre-order. Next we'll jump into in-order, and then in-order is also very simple. Here you're gonna have left, node, and right. You can pause the video, you can check for the output, and you can verify here. I'll directly be coding here, and I'll show you can pause the video here and then resume, and then you can check the output, and then you can go for the code. Welcome back. Here's the output. So now we'll be coding for it. This is also again pretty much simple. So we'll just go easy on it. So it's pretty much the same as how we coded the pre-order. So if roots left exist, then we go in order roots left, and then we just print the data of the root, and then if roots right exist, then we go in order roots right. Okay, that's pretty much it, guys. That's it. It's very easy, and we'll just call the function again. In place of this, let's just go here and let's just go in order traversal, and let's just go here in order as well. Okay, just run and see. My bad, I'm sorry. Let's just run and see. Perfect, guys. 48251637, and that's pretty much what we got here. 48251637. So then we have the post order. This is again it's something where you can do it on your own as well. We can directly be coding for it. This is again very easy. It's left, right, and node. So first you go left, nothing there. Then you go right, you get 8 printed out, and then there you get 4 printed out. So that's pretty much it. It's very easy. It's left, right, and node. So we can directly go code for it. So here you go. So we have post order, and we have a root here. So this is left, right, and node. So if roots left exists, then post order roots left. If roots right exists, then post order roots right, and then you just print roots data. Okay, that is pretty much it. So here you can check out them as well. Let's copy paste, and here you have post order, and you call the post order function. Okay, here you go. 845267131, and here you have 845267131. So that's pretty much post order. Here comes the most important part. It is level order, and guys, we are not really going to code for it, but it's again one important traversal which you need to know. You will be seeing level order very soon for that. So I'll pretty much explain what is level order. You can try it as a homework. Otherwise, we can upload videos for that. We will upload videos for that soon. So here you go. Let's explain level order. This is very easy. You have this as your level 0, this as your level 1, and this as your level 2, and this as your level 3. So that's pretty much it. First the level 1 gets printed. So 1 is getting, level 0 gets printed, so 1 gets printed. Then we have level 1, 2, and 3 which gets printed. Then 4, 5, 6, 7 which gets printed, and level 8 which is going to print it. Don't worry if you don't know the code, guys. We will be coming up with the code very soon.
So Sampath, you mentioned that your hobbies include racing. Is it true?
Yeah, I like to break the laws sometimes.
So who's your favorite racist?
Oh, you, man. Alright, I'm out of here.
Hello guys, this is Aswin from BreviTV, and I'm going to teach you the search traversals of BFS and DFS. Without wasting any further time, let's directly jump into the topic. So this is the node or the graph where we are going to perform our breadth first traversals. You can consider it as a tree or also as a graph, it doesn't matter. So let's see how we are going to do BFS and DFS in it. So let's start with breadth first traversal. And before going into breadth first traversal, I'll give you a small hint on how it occurs. Just notice how breadth first traversal appears again. Did you notice that it occurs word after word? That the first breath occurs, and then first occurs, and then traversal occurs. That's pretty much how breadth first traversal also takes place. It takes place level after level. Let's perform it on our tree or graph. So here you go. Here we are going to perform BFS on it. So first we start with 1. So after seeing 1, we print it. Here you go. Next, 1 is connected to 2 and 3. So we go to this particular level and then we're gonna print 2 and 3. Notice that this is not the only order it can be printed. It can also be printed 3 and 2. There are various permutations. And therefore, 2 is connected to 4 and 5 and 3 is also connected to 6 and 7. So the next level is going to be printed. Again, this 4, 5, 6, 7 can be printed in any order. This is not the necessary order. And then the last level, which is 8. That is very much pretty breadth first traversal. It's more or like a level order traversal which we perform in a tree. Very easy and simple. Just that the order of which the outputs occur might change. We are done with breadth first traversal and we are here to go to the depth first traversal. Notice how the depth first traversal occurs again. Here's a hint for you. There you go. So it pretty much, whenever you see a depth, in case if the other is also present, we also print that. And again, in case F, we go down, and if T is printed, we also print T. Don't think much about the traversal. That's because, it's a big word and there is nothing much here to say. But anyways, let's perform it on the world and see. Here you go. Here's our world. So we are going to do a depth first traversal in it. First, let us look what are the depths available. At the bottommost we have 8, and then before that we have 4, 5, 6 and 7, and then we have 2 and 3 in one level, and at the topmost, which is 1. Okay, so let's just go and see how this depth first traversal works. So we start with 1 and we see 1 is connected to 2. Again, it's not the only order, it can go right side as well, but let's keep left. 1 is connected to 2, 2 is connected to 4, and 4 is also connected to 8. So we print 8 first. There you go. Once 8 is done, we see 4 if it is connected towards other. It's not, so we print 4. Similarly, we just go and print other stuffs as well. This is one such output which I am going to show you, or one such order in which depth first traversal can occur. The other order which I'll also show you is what if 1 gets connected to the right, and here you go. If 1 gets connected to the right, we go 3, and then from 3 we can either go to 6 or to 7. So it pretty much happens. This is another output which I'm going to show you. First 6 or 7 might occur, and depending on the first, the other things will occur. And then once this is done, the 3 will also occur. And subsequently the other outputs as well. This is again one such order in depth first traversal. There is no specific order, you can go by any means. It varies from computer to computer, or system to system, or probably operating systems. That's it guys, this is a small introduction to BFS and DFS. If you have any doubts, please let us know in the comment section. And please like, share and subscribe our channel. And thank you for the opportunity. Thank you for listening to our video. Please help us, and we are always here to help you. Thank you very much.